Hey guys, it's Tiny Maths back with another video. By the way, if you guys are looking for the video on triangle proofs, I've made a newer, more clear video on that. I've linked to the new video in the description, or you can watch today's lesson and click the end screen at the end of this video, since I've linked to it there as well. Corresponding and alternate angles of parallel lines are the angles that result when you have two parallel lines and you have one straight line that crosses through both of those lines. This line I'll highlight in red to emphasize it. Today we'll explain how you identify alternate and corresponding angles. Then, if you stick around to the end of the video, I have two example questions for you to try out. You can use what you've learned today to see if you can solve the questions. And while you're thinking about whether you should stick around or not, why not smash the subscribe button and like the video. You'll help YouTube recommend Tiny Maths videos to other students out there looking for help on their maths journey. The red line passing through both parallel lines at an angle is called the transversal. It creates two intersections, one above the other at a slight angle. Note that at each intersection, four angles are created. Each of these can take on several different identities: corresponding angles, alternate angles, or supplementary angles. That means that each individual angle can be labelled as any one of these three types of triangles. We will deal with supplementary angles in another video. Now, the individual angles are neither corresponding, nor alternate, nor supplementary by themselves. Now that might sound strange at first, but what I mean is that they are only called those names, that is corresponding or alternate or supplementary, in relationship to other angles. For example, this angle on the top right hand side of the upper intersection is neither corresponding nor alternate when it is by itself. What makes it a corresponding angle is a reference angle we are comparing it to. So for instance, let this angle in red be our reference angle. Then our yellow angle is a corresponding angle of the red angle. You could flip the reference to being the yellow angle, and then you would say that the red angle is a corresponding angle to the yellow angle. Actually, they correspond to each other. That's their relationship. They come in pairs. But the yellow angle can also be an alternate angle. What would make it alternate? It is this reference angle here, the green one. So the yellow angle is an alternate angle of the green angle. The yellow angle is alternate or corresponding depending on the position of the reference which we are comparing it to. Remember, they are an alternate pair, so they are alternate to each other. The yellow is alternate to the green, and the green is alternate to the yellow. The most important rule you need to know about corresponding and alternate angles is that angles that correspond to each other are the same size, and angles that are alternate to each other are the same size. Corresponding angles can be thought of as pairs of angles. We saw the example of yellow and red angles corresponding to each other. An easy way to identify a corresponding angle is by observing that the corresponding angle lies in exactly the same position, but just on the other intersection. So the red angle is on the top right corner of the intersection it is on, and the yellow angle is on the top right intersection it is on. And that's how you know how you have corresponding angles, because although they are on different intersections, they occupy the same position on their own intersection. That then means that the angles on the top left of each intersection correspond to each other. The same with the bottom right angles of each intersection, and the same with the bottom left angles of each intersection. So there are four pairs of corresponding angles. Now alternate angles are less easy to spot. Let's take our yellow angle again. Now notice what happens if I flip the whole diagram 180 degrees from the middle of the transverse. Did you see where the yellow angle ended up? Yes, down here. if you flip your diagram around 180 degrees, the angle will always end up in the position of its alternate pair. So the yellow angle is alternate to the angle in that position. Let's flip it back and fill in the other angle with the color blue. Now, when we flip the diagram, the yellow lands exactly in the blue angle's position. This means that the yellow angle is alternate to the blue angle, and vice versa. The blue angle is alternate to the yellow angle. They are alternate to each other. You can try this for yourself with any of the angles. Draw an angle, flip the diagram 180 degrees, and the angle will end up in the position of its alternate pair, the angle which it is alternate to. The other three alternate pairs are as follows. So, there you have it. That's how you find alternate and corresponding angles. Now, let's try a few questions to see if you've understood the basics. First of all, look at this angle here. It's on the top left of our upper intersection, and I've colored it orange. So the question is, find A, the alternate angle to the orange angle, and B, the corresponding angle to the orange angle. Why don't you pause the video and see if you can find the answer to A and B. I'll wait, then I'll come back and give you the answers. So, do you remember how to find the alternate angle? We simply flip the diagram around 180 degrees. And the position which the orange angle lands in, that's our angle. So, the blue angle is the alternate angle to the orange angle. Now part B. Can you find the corresponding angle to the orange angle? Well, simply note that the orange angle is on the top left of its intersection. So that must mean that the corresponding angle to it is on the top left of the other intersection. So here we have it. The green angle is on the top left of the bottom intersection, which means it is the corresponding angle to the orange angle. Now to our second question. Find the value of x. Now since we want to find out the value of x, we need to work out the value of the angle 2x first, and then divide by 2, and that will give the value of x. Now my first thought with a question like this might be, is the angle 2x the same size as the 120 degree angle? I don't know, but how would I find out? Well, remember that alternate pairs are the same size, and so are corresponding angle pairs. So if I suspected that the angle 2x is the same size as a 120 degree angle, I would check to see if the angle 2x is either a corresponding or an alternate angle to the 120 degree angle. And if it turned out to be either one, then 2x must be the same size as 120 degrees. Now I can tell you that 2x is neither a corresponding nor alternate angle of the 120 degree angle. So we're unable to show that 2x is equal to 120 degrees. We don't know the value of 2x. If you don't understand why I'm so sure that 2x and 120 degrees are neither corresponding nor alternate pairs, I want you to pause the video and try to actually find the alternate angles and corresponding angles to the 120 degree angle. And sure enough, you should find that they are not in a position of 2x. We'll have to do something else. But there's one thing we could do. We could ask ourselves where the corresponding angle of 2x is. Now you know how corresponding angles work, you should see that it is on the bottom left part of the lower intersection. So this angle here is the same as 2x. Let's label it so. Now look at these two angles. We now have two angles together that completely span a straight line. What's the sum of angles on a straight line? Yes, 180 degrees. So that means that these two angles, 120 degrees and 2x, add up to 180 degrees. In other words, 2x plus 120 equals 180. we can rearrange the equation to get that 2x equals 180 degrees minus 120 degrees, which equals 60. So 2x is 60, which means that x equals 30. And there's your solution. So, by showing how your corresponding angles work, you were able to calculate the value of an unknown angle given the value of another angle. You could have chosen to do it another way by finding the alternate angle of the angle 2x. Try that for yourself and see what happens. You should still be able to arrive at the same answer. So there you have it. You now know how to spot corresponding and alternate angles around parallel lines. Hopefully you'll be able to handle questions where this skill is needed. And don't forget to watch my video where I use knowledge of alternate angles to prove that the angles of all triangles add up to 180 degrees. Just click on the end screen card that will appear in a moment. Well, that's it for now. Hope you enjoyed the lesson. Until the next time, take care.